Hi, myself T. Prasad. I am from Civil Engineering Department. So today we have to discuss about the Theodolite surveying and Tacheometric surveying. Now coming to the Theodolite surveying, which survey is used to determine the horizontal angles and vertical angles by using the Theodolite instrument. The type of survey is known as Theodolite surveying. Next coming to the Theodolite instrument. In this Theodolite instrument is used to prefer the horizontal angles on the ground surfaces. It can be a telescope is inverted to the horizontal axis on the vertical plane on the horizontal box. This is the parts of the theodolite instrument: telescope, spirit bubble, horizontal vane, and spirit bubble, vertical plane, lower clamp, and upper clamp, and foot screws. What is the use of objective vane of the telescope? Is the instruments is used to preferring the eye vane to carrying the sight the points on the ground level is known as the objective vane. Next, what is the use of foot screws? In this foot screws are used for the certain ground level onto the tripod stand. Now coming to the theodolite surveying, the classifications. These are the two types of classification. First classification is repeating theodolite, next directional theodolite, next electrical digital theodolite, next second one is classification 2. In this classification 2, primary classification of theodolite and electronic digital theodolite of the theodolite instrument. Next coming to the types of theodolite: transist theodolite and non-transist theodolite. In this non-transist theodolite is not revolving through the telescope, revolving the evolution in the horizontal axis of the vertical plane. That type of theodolite is known as non-transist theodolite. Next coming to the transist theodolite. In transist theodolite, the telescope is complete revolution on the horizontal axis of the vertical plane of the instrument. That type of theodolite is known as transist theodolite. Next coming to the cross section of the theodolite instrument. This is the vertical scale and vertical axis and line of the sight of the telescope. Next the main axis is the horizontal scale. In this theodolite instrument, two scales are inserted in the horizontal box of the theodolite instrument: main scale reading and vernier scale readings. In main scale reading, the readings are inserted into the theodolite is degrees and minutes. Next, vernier scale reading, only the seconds and minutes are inserted in the vernier scale readings of the theodolite instrument. Next, classification of theodolites. Theodolite instruments may be classified into the two types, A and B. A means becoming the transist theodolite, non-transist theodolite. Next, B becoming the vernier theodolite and micrometer theodolites. Next, measurement of horizontal angles by using the theodolite instrument. These are the three experiments should be done on the ground level by using the theodolite instrument. First one, ordinary horizontal angles. Next coming to the repetition method. Next, third one is reiteration method of the theodolite instrument. These are the three methods. Now coming to the repetition method. In this repetition method, the center point on the ground is fixed on the center point to locate the O, to fix the instrument to the tripod stand to instrument, to fix the horizontal and angles, to fix the opposite direction of the two poles, to fix the ground surfaces, pole A, pole B, to fix the instrument certain plane level on the spirit bubble and with the using the foot screws. Next, to fix the scale 0 degrees, 180 degrees from the scale A reading, scale B reading 180 degrees. These are the two scales, scale A, scale B. To fix the instrument, lower clamp is tightly fix the instrument. To release the upper clamp of the instrument to sight the point A to point B. To form the reading is 30 degrees. Now coming to the to fix the upper clamp of the instrument of the theodolite and to release the lower clamp of the theodolite instrument is freely to release the instrument and to resulting the to form the point A pole. The angle is same 30 degrees. Now coming to the simultaneously same process, we have to fix the instrument to release the upper clamp of the instrument of the theodolite to set and form a reading 60 degrees. Now coming to the same process to fix the upper clamp of the instrument of the theodolite and to release the lower clamp of the theodolite to exchange the point B to point A. The value is same 60 degrees. Now coming to the same simultaneous same process to fix the lower clamp of the instrument to release the upper clamp of the theodolite instrument to form the angle point A to point B to form the angle 90 degrees. Now coming to the what is the procedure of repetition method. In this repetition method now repeats the repeating angles to form the point A to B, B to A to forming the angles. Number of angles should be formed. To forming the 7 to 10 times. To final reading is vernier is almost thrice the angle. Next coming to the divide the angle by the 3. You will get the final angle. Repeat these two steps 2 to 9. Determine the angle with the right face of the theodolite instrument. Now coming to the calculation table for the repetition method. This is the PQ. This is the O, instrument station. This is the instrument station O. This is the pole P, Q or S. This is the calculation part of the repetition method of the horizontal angles by using the theodolite instrument. Next, how to find out the mean value of the horizontal angle. To fix the instrument ground level 0 degrees 10 minutes and 10 seconds of the first scale A. Scale B reading is 180 degrees 10 minutes 20 seconds. The least count of the theodolite is 20 seconds. This is the scale A reading, scale B reading. To fix the upper clamp of the theodolite instrument, to release the lower clamp of the theodolite instrument, to forming the angle point A to point B, to forming the angle. The separation of the variation between the angle A to angle B, subtract the included angle. Next, coming to the reiteration method of the theodolite instrument. What is the reiteration method? To compare the repetition method and reiteration method. In this reiteration method, to fix the central level of the ground level, fix the point O. To form the in surroundings of the ground level, to fix the ranging dots A, B, C, D. The whole surroundings of the land. To center point of the instrument is point O. To fix the reference line, one reference line to form the fix the instrument to forming the scale A, scale B readings. To fix the scale A, scale B initial readings are 0 degrees, 0 minutes, 0 seconds of the scale A reading of the theodolite instrument. Scale B reading of the initial reading of the instrument is 180 degrees, 0 minutes, 0 seconds. This is the initial reading of the instrument. To fix the lower clamp of the instrument is fix. Upper clamp of the theodolite is freely to revolve. To form the reference line to point A to form the angle theta 1. So for example, the set and forming the one angle. Next, simultaneously same process to fix the reference line to point B. This is the theta 2 reading. Next, to form the reference line to point C, to forming the theta 3 angle. Next, simultaneously same process should be done on the ground level is to fix the upper clamp of the theodolite instrument is freely to revolve and lower clamp of the instrument is fixed to forming the reference line to last point of the pole is theta 4. These are all the 4 angles to be formed on the ground level. Theta 1, theta 2, theta 3, theta 4. These are the 4 angles should be done in the measurement of the M book on the table. Suppose it is the required to measure the angles AOB, BOC. Next, coming to the COD. These are the number of triangles should be formed the angles. Next, this is the graphical representation from the ground level. This is the instrument to form the reference line to point A, point B, point C, point D to forming the angles to locate the alpha 1, beta, gamma, theta. These are the 4 angles should be done on the ground level. Now coming to the measurement of horizontal angles should be done the simple ordinary method to fix the instrument on the center line method on the ground to fix the pole A, pole B to forming the initial reading of the theodolite is 0 degrees, 0 seconds, 0 minutes in the scale A reading 0 degrees, 0 minutes, 0 seconds. Scale B reading of the initial is 180 degrees, 0 minutes, 0 seconds. To set up the theodolite station point O and level it accurately. Next, coming to the point A to point B to locate the horizontal angle to be formed. Upper clamp of the instrument is freely to revolve and lower clamp of the instrument is fixed tightly to form the angle. This is the calculation table of the theodolite horizontal angles. This is the scale A reading, scale B reading, scale A, scale B to forming the number of triangles. The variation between the first angle to second angle. Included angle. This is the included angle. The variation between angle 1 to angle B. These are the finally we have to get in the included angle from the theodolite instrument. Next, this is the vertical angle method by using the theodolite instrument. In this vertical method, non-transist theodolite is used for the vertical angles to be formed in the ground level. Angle of elevation, angle of depression. This is the angle of elevation, angle of depression. First point, single side A as before take the mean of 2 vernier readings at the scale A and scale B readings. Next, similarly point B, the forming the scale A and scale B readings should be formed. The upper portion of the theodolite pole is angle of elevation. The downwards to be forming the angle of depression by using the theodolite instrument. This is the vertical angle method. This is the instrument to be fixed on the ground level. Pole is fixed on the ground level. To forming the vertical angle. This is the angle of elevation. Angle of elevation. Next, angle of depression. Downwards. So, angle of elevation. This is the angle of depression. This is the beta. This is the alpha to be locating the angles. Next, what is the procedure to be finding the horizontal angles? Angle of elevation, angle of depression. Suppose the angle of elevation triangle AOC, the upper portion of the right angle triangle to be forming the angle of elevation. Alpha tan theta equal to opposite side by adjacent side to forming the theta 1 value. The downwards right angle triangle to be forming the angle of depression. Triangle BOC to be forming the angle of depression. Next, find out the height of the building by using the Theodolite instrument. To fix the instrument certain distance on the ground level before the building or pole anything else, to be fix the instrument to locate the distance from the center point of the instrument to the building base. This is the distance D. This is the to be forming the angle of elevation should be noted theta 1. Next, coming to the angle of depression should be noted theta 2. So, instrument height will be noted h1. So, tan theta 1 plus tan theta 2. Finally, you get the height of the building. Tan theta equal to opposite side by h by d. H means height of the building. D means distance. So, theta 1 values. Next, theta 1 means this is the angle, 45 degrees. So, for example. Next, simultaneously same process should be done in the angle of depression of the Theodolite instrument. Next, this is the calculation part of the height of the building. Tan theta equal to h by d. H means height of the building, distance, theta is equal to 24 degrees. Finally, we have get the h equal to 222.614 feet of the building. This is the calculation part of the height of the building. Next, these are the two experiments should be done in the Theodolite instrument. Base of the object is accessible condition and base of the object is inaccessible condition. Base of the object is accessible condition means the instrument is fixed before the building or any tower to fix the instrument. To measure the distance equal to like 6 meters. So for example, to forming the instrument height should be noted h1 is equal to 1.63 meter. To forming the angle of elevation alpha 1 theta 1 equal to 49 degrees. So we have to get the formula. This is the right angle triangle. Tan theta equal to opposite side by adjacent side. So opposite side means we have to look at identifying the h. So adjacent side means d. Tan theta equal to h by d. So h equal to d tan theta on h equal to finally get the height of the instrument. So S1 means instrument height. S1 means instrument height. Instrument height plus h equal to total height of the building. The base of the object is accessible condition. So visible condition. Next, coming to the base of the object is inaccessible condition. This is the diagram of the inaccessible condition for the Theodolite instrument. To exchange the instrument for the inaccessible condition. To fix the instrument, first point A, station A, to locate the height of the tower, to locate the same distance, to denote the same formula tan theta equal to h by d. H equal to d tan theta 1. So simultaneously, next coming to the same instrument should be shifted from point A station to point B station. Simultaneously same process h equal to d tan theta 2. So simplify the two equations. Finally, we have to get the h equal to d tan theta 1, h equal to d tan theta 2. These are the two equations. Simplifying the finally, you have to get the base of the object is inaccessible condition of the Theodolite surveying. Thank you.